Yes, I believe we are live now. I think. Sorry, I'm 2 minutes late. That has never happened before. I'm always on time. The stream health seems orange. I hope that's right. Otherwise, I could fix. Like normally, I'm connected over Wi-Fi. I could connect over cable if it's gonna be really bad. But before we start, let me just tweet the URL as usual, and then we can get started. There we go. Oh, a bit rusty. It's been some time. I don't know, a month, two maybe. I don't know. But yeah, I've been taking a small break from kicading, just doing like actual CADing, like 3D modeling here in Fusion. I have some stuff. So yes, I created the project already. I have latest KiCad nightly. But before that, I could discuss slightly what we're gonna do today. I have some things loading here. Yes, so today we will be creating a LCD breakout board for these really cool 3.95-inch LCDs that I got from Alibaba that I'm thinking of using in my portable handheld Linux device. And since I don't have the STM32MP1 design finished yet, and I will finish that, don't worry, it's just that it takes longer than I expected for STM to actually release that chip or even the discovery boards for that. So it's gonna take some time still to actually get those chips. So meanwhile, I can do other parts of the design. Like I did the charging and fuel pump stuff, and I did the audio. Actually, I'm gonna do the USB power delivery stuff. I have the boards and now I have the parts also, so I'll be doing that tomorrow actually. But mean videos output is low. You know what? Let me just 1 second. I'll try to fix the internet. Okay, let's see if this fixes. It might also be that just there we go. I'm copying some files and my PC is not super happy because of that. Let's see how it goes. Hopefully it will be better once this is done. Or actually I could 1 hour. Oh no, screw that. It's just I was updating the 3D model libraries, but I don't need those right now. So hopefully it will pick up soon. Not sure what else I could do. Yeah. So yes, that's what we'll be doing today. A quick breakout board for this LCD. And since, yeah, now I'm repeating myself. Since I don't have the STM board yet, I will be using a Pine A64 board, which also has DSI. Just because I had that board, there's no real significance to that board. I mean, DSI is just DSI, Linux is Linux. So if it works there, it should work anywhere. And then, yeah, so that board, which I believe I have, yeah, I thought I had an image here of it. No, not SD connector. Damn you, search history. There we go. So this is the board. It has this nice connector here for DSI, but it's obviously not the same pinout as the LCD, so I need a small board between. And there's also backlight control. Oh my god, why is the neighbor making noise? There is backlight on that, but I won't be using that one just because I want to also test the backlight circuitry that I will later put on my board. So let's do that. Work harder. Simon, you threw me off. Yeah, so we will make a board that connects this one to the LCD. But before that, I could actually do one thing that, let's see if it works, because I'm curious too. Let's see. Damn, I just realized you can't hear my voice when I switch the camera because of how this is set up. Just give me a second, I can fix this. There we go. I believe you should be able to hear me now. Sorry about that. I'll have to start over. Can you still see? And I believe you should be able to hear. So yeah, let me start over, sorry. This is the LCD that I got from China that I will do the breakout board for today. Here's the connector, not so many pins on that one. It's just the DSI, backlight, power, and yeah, that's pretty much it. But it is 30 pins, so still have to make a breakout for that. And the focus on this camera is great. And as I was saying to myself, apparently, here is the 3D print form factor test of the handheld device. I mostly wanted to test the keyboard, like just look and feel pretty much for it. So yeah, I don't know if the height and the shape of them is final. It's probably not. And then here I scraped off the LCD like stand-in just so I can put this LCD kind of and see it like that. So so you can have a look like this. And I think it looks quite alright. It's a really big display, like when you see it like this, and when you see it in my hand also, it's quite big, but I made it already smaller by removing one column, shrinking the keyboard slightly, and now you can see, like in my hands, it is, like I can reach to the middle, no problem. I can reach over, which was a big thing for me. I don't like these huge keyboards where you can't reach. I don't know if it's my hands are small or something, but I want it to be like, this is the perfect size for me. And I did ask people to 2D print and 3D print those, at least like 2D print, so they could tell me also how does it feel in their hands, because I am curious definitely for that. So yeah, and I know some people pointed it out that I should look at the BlackBerry Q5 keyboard, and oops, and I definitely have been. This is a BlackBerry Q5 taken apart, and like, not sure if you can see it here, but there is definitely some there is inspiration, and by inspiration I mean just copying, because the size of these keys is, yeah, it's exactly the same as on the Q5. And because when I got the Q5, I was actually very pleasantly surprised how good it feels, like typing on it. Just, it's really nice. I mean, right now it's taken apart, so it's slightly harder, but you can see how much you can see on this resolution, but it's really, like, really well sits in your hand, and typing on it, it's really nice. The keys are slightly, like, this side has a slight curve on the surface, so it's easy to press with the right thumb, and then the other side has the other way, so it's easy. And I will definitely try to do something similar here, but that is hard to 3D print in, like, with like PLA and so on. It's just, you don't get that those tolerances, that resolution there. So that's something for the future. Yeah. So if you need size comparison, here it is to a Q5. This one, it's, there you go. I should have the display. Oh, there's a panel with a display. And yeah, if you're curious how the Q5 keyboard works, actually, it has this, not really silicone, but plasticky membrane that presses on these metal dome, metal domes that are covered by this sheet of plastic. You can't see, but there's backlight there also. And so, actually, here's you can probably hear those presses there. Yeah, on a side note, it seems the stream health is good now, so I think stopping the copying helped. But yeah, making a design like this is quite hard from multiple reasons. One is, like, making this, like, how do you can't really 3D print this good enough with like FDM, maybe SLA. I'm hoping, because that's what I'm thinking here. I will create all these buttons as this kind of pad with flexible resin, so hopefully that can work. But also, just doing this, you have a PCB. Yeah, I can't really, like, you have the PCB with these special, yeah, I can't remove that, never mind. With these footprints, and then you put a metal dome for each, and that's already, like, I tried to print a small, like, 3x3 and putting metal domes. It's really hard to align them, and then you have to have something on top that sticks, that keeps them actually in place, and that's also kind of difficult, getting proper glue and so on. So so for this one, I'm thinking regular buttons, like tiny buttons under a membrane thing, and hopefully that works. Let's see. But yeah, enough of this talk. I think that was all I wanted to show, just to show off my crappy camera. But yeah, I think it looks quite nice. Yes, so now I can switch with my Star Wars zoop effect here. And let's see, I need have it open here. The datasheet for this display. I did not sign an NDA or anything like that for it, so I think it's fair game. And there you go, there you have the pinout. As usual, the boring part of the KiCad process, so too many rotations, is creating the symbols, and obviously I'll need to do that here also, so bear with me. Let's just give it a second. The stream might slow down slightly because this is CPU heavy, and that seems the stream likes to hog the CPU. So when something else is taking the CPU, the stream slows down. There we go. That wasn't so bad. And new library. And again, I've been saying, since last stream, I need to organize my footprints and symbols so I can like publish them, but I haven't gotten around to it yet. I believe that's how they call them. I will. Let me just double check graphic. Perfect. Cool. So there is the name. I think this should be pretty fast actually. Yep. Right. And there we go. Because as I showed the pinout, like so many, you can see here so many NCs, like we skip all of these, and the ground will go super fast. So it should be nice and fast. Actually, I haven't used KiCad since I last streamed, so I hope I didn't get too rusty. Right, so here it's slightly funny that here you have 2 pins for the cathode of the LED, but if you see here this diagram of the backlight, the cathodes are actually connected here, so it's 2 strings of 6 LEDs, and in the actual flex of the LCD you can also see that just here those 2 pins go in and then connect into one and just continue as one, so you can't treat them as 2 strings. It is just one, and that's what we do here. There we go. And then IOVCC. That's an output. Fairly sure reset is active low, so I will double check when I'm down with the pinout. And then all these grounds here. So let's see, pin 8. And then it's also pin 9, pin 12, and you know what, actually let me change here. I can there's no duplicate here. I remember. It's strange. Where was I? 12. And then 15, 18, 21, 24, 30. But there's really no, I haven't found a good way to do this. Yeah, faster than this way. And 30. All right. The ground, and then we just have 2 data lanes and a clock lane. There it is. And data 1 positive, or data 1 positive. We can do it like that. Visible, bidirectional. You know what? I like it actually more positive. And the next one is negative. And then 0 positive, 18. 0 negative on 20, right? That. And then clock positive on 16 and negative on 17. And there you go. And that's actually, I think, all of them. Yep. Ground, 10 and 12. Correct. Correct. Cool. Then whoop, too many rotations. Let me just 100% verify that reset is active low. If I can find it. Okay, we assume it's low because it doesn't. There's no like boot up sequence, stuff like that. Nope. Alright, so that's IOVDD, and that's just power supply VCI 2.8, 1.8, tearing. Yep. Well, this is really useful. They just did not try at all. 1 3 o'clock. Yeah. All right. We can move this here. And there we go. Nice little symbol. And there you go. Our input, input, output, input. So that should be actually on that side. Or maybe on the bottom. All right. That's this, that's that. There it is. There's the display for you. Two viewers, and maybe is it early in the day to stream, or is it a bad day overall? I wonder. Or did people get discouraged by the crappy quality at the beginning? Oh well, who knows? I will get to the rest of this. Then we need a connector for the Pine side of things, and I do have that schematic. I did have that schematic. There it is. There we go. So there it is on the Pine side, and yeah, one is here, and then it says 32 just because the two side connectors are also marked here, which we want to do. So I won't be creating, I don't think I will be creating a symbol for that. I'll just use a 1x30 header symbol. No point in overthinking that part. There you go. Especially since I won't be reusing this in the later any later designs like this. I will be using, I can use this again when I use this display again, but not the Pine connector, fairly sure. Right, not 100% sure if the symbol for the actual connector will match like 1, or is it 130, but it doesn't matter, I can flip it very easily, so as long as I have all the pins, we are good. Yeah, most of these actually won't be connected at all, and I have yet to check the voltages of these, so we'll figure that out in a second. Yeah. Sure, let's add all of them. Oh, I was hoping it would be smart, but nope. Voltage high. Voltage low. It kind of changed something because I believe it used to be you pressed P and then the power dialog just showed up. Now I have to press P and click. Or I guess I can do P and enter. Space? No? Wow, I actually have to go back to the mouse. That's silly. Wow, this nightly is not behaving so nicely. Duplicate, there we go. So 13 and then another ground at 16, 19, 22, 25. That's it. Yep, so 11 is D3 positive. Something's either they changed some behavior or this nightly is not so good. See, like I can't press enter to place. That is wow. D2 positive, D2 negative. Clock positive, clock negative. On 20, D1P, D1N. And finally, on 26. And 5. 27 is nice. Reset. 28. 28 and 29 connect to 1.8. Perfect. And 30 connects to VCOM, which I believe is 5 volt, but let's double check. There we go. Sorry. Is this a good time to check VCOM? Sure. So this claims VCOM is 4.3, which seems strange. Here it claims it's 5. CNC. Yeah, I believe that makes it sound like it's a 5 volt. There's 1.8. Reset is right. Don't know, 2.8, maybe one of these. I need to also check those. Right, so for now, just let's code vcom. Yeah, there we go for that one. Then, funny enough, oh, I closed the data sheet for the display. Let me just open that up quickly. Yeah, and when I say quickly, I don't mean too quickly. Oh, seriously, come on. Got it. Right, so it's the I/O. That's 1.8. So we can do this. There we go. Seriously? You gotta be like that, Kicad. I blame the nightly. Alright, then we can already connect these. Sure, I don't need the ground actually. So there's no tearing, and I don't need it. I might actually, I will put it on a test point because it costs nothing, but it might be helpful. Right. To be sure not to screw up the polarity. Yes, I might be hard to bodge wire later since it's so high speed. Oh, are you serious? Huh. Something strange there. Right. I reset. We can connect also actually just directly. Easy peasy, just not even a breakout, just a converter board more than a breakout. And wait, what there? Did I undo or did it disappear? Did it crash? What the heck happened? Seriously. See, there's drawing issues. Like this one is not before that one was like grayed out. Yeah, but that's the nightly life for you. So anyway, 2.8, I will need it regardless if I have it or not. If I don't have it, I will make it. Cool. And there you go. Should I? Oh, let's do one. Okay, that's downloaded. Never mind. Should I assign the footprints already? So let's see, I found connectors that should fit. It's actually funny because the connector flex for the display and the one that's on the Pine, it's actually the same. It's like 30 pin, it's 0.3 millimeters and 0.5 pitch, all that good stuff. But obviously the pinout is wrong, so I just can't connect it. But on the positive side, it will be the same connector for both. I did find one, and I do wonder if it's actually in KiCad. Could be. So we'll see. And then to connect the Pine to this board, I need a flex 0.5, also 30. So I have these two. This is what we will be using for the backlight. I'll circle back to that. But let's see the footprints actually. Because there is a lot. So okay, it's not that many. Maybe it's kind of strange the way KiCad does it. It's better now than it used to be, but like look at this. Connector HDMI, that means all the HDMIs are here. Okay, but then there's a connector Molex, and that's where all the Molex are. So like sometimes it's by function and sometimes it's by brand. Like Samtec, that's a brand, and yeah, it's strange. I get that it would be hard to create all the categories, but it's still slightly strange. So now I was wondering if there is a Amphenol category, but there isn't. So it seems like there is no connector unless, let's see, 30, like would this fit? That's a question. Is there a 3D model for it? No, of course not. I mean, it doesn't take that long to create a footprint, but it takes more than 0 seconds. So if I can spend a few seconds just to find one, they're all pitch 1, and that's the problem. This pitch, yeah, it's exactly 50 pitch. The good thing is that I do have a 3D model from what is it? Amphenol. Sounds like some drug. So I had a step file from them, and here in Fusion 360 I added some nice colors to it, so it doesn't look so sad. So what I can do is actually place this 3D model on that footprint and see if it fits, because this is scale 1:1, so if it fits, then it fits. Oh yeah, here I have a render also for the display. I posted like a video, sped up 8 times, I believe. It took like 10 minutes to create this, so it was like a minute. Model for the display. I can have it for later, because I thought on this board actually I would put it on this board, but no, because this board won't be as big as the display. I just want like 2 connectors in the backlight, so it's gonna be tiny, and then the actual display will be on the side, on one side, and then the Pine on the other side. So I didn't need this model right now, but it's nice to have it. I can prototype some other stuff. So actually, yeah, let's see if it fits. And for that, I actually have to go to the way I mounted this camera on my monitor is actually it's right in the way of this icon. I can't see it. Okay, it's still loading. No, there's no filters. That means it's trying to list all the footprints, all of them. So again, the stream might get slow for a second. Oh, actually, it is filtered. Okay, just really slow. So now we can do this. And there we go. Yeah, so there should be a model for it, but there isn't. Let me just... Good. I know where I put it actually. Just 1 second. I totally didn't delete it from my desktop when I was just cleaning stuff up. Totally did not do that. What was the name of that? It was like one something. There it is. Restore to desktop. Right, so now it should be on the desktop. I was just trying my desktop to be nice and clean, but loading. There it is, and it seems too small. That's gonna be hard to mount. I never remember which way models are oriented in Fusion. I shouldn't have to. Wait, what? No. Okay, that's definitely broken, because why does both Z and X rotate? What the hell? Really bad. Okay. Okay, that was... I don't... Never mind. That wasn't right. So maybe actually... Nope. Look at that, this could actually work. Or I could at least clone it and slightly modify it because it's way too big. Also, where the heck am I? All right, I didn't save the changes with the colors. Yeah, that's why there's no colors here. I could actually do that in a second, but that's cool. Where is it? Very cool. Yeah, it's way too big, but it fits perfectly the pitch, and even these guys here align quite alright. Right, because the moving part is here, so it's no problem. I insert the flex here and then close the door on it or latch it. All right. So this is a very good, okay. I can make my own based on this, just move something slightly around. Yep, cool. But before I do that, while we're here, let me just save this nice 3D model. Desktop, sure. Saving. And save, I believe. There it is. So I can place it in already in the project folder. Sorry, I'm doing it off screen just to the other monitor. And then the name. And his name. There it is. Okay. So, right, I don't want to lose these. So, actually, there's the path, and now if only I remembered. Where's the project path? Blanking archive, project mod. Come on, path. Come on, KiCad not crashing. There, oh, cool. So, minus 90, minus 90. See, this is. Oh wait, how is this even possible that it's aligned correctly? Did I actually move it? Maybe. I mean, it's incredible how so much better it actually looks with the colors. It takes some time to add the colors, but I believe it's so worth it because it looks just so much better. I mean, it's not just a gray blob. All right, there we go. So what we can do, I'm just thinking of order of things. Should I do this now or later? But I will already add it, and it's both the connectors, so it's needed definitely. So let's just go for it. I need a new library. Pretty nice. What was it? Amphetamol? No, that's something. Seems like something else. Amphenol. Amphenol. Sure. And then copy. And I paste. There we go. Need to rename it, which I believe is here. Yes. Do I have it open somewhere? I do not. Yep, that's the right thing. Then we have the data sheet for it. Generated with footprint. Cool. Right, I have to copy from. Right. Wasn't there a data sheet here? No, that's in the symbol. Yes, that's correct, actually. You were correct. So, okay. here for 3D model. Wait, wrong button. Should actually be like, yeah, there you go, because it's in the same folder. I haven't really found a way to, like, I don't have a standard convention of how I do this. So this is good enough. Cool. So just do not spend too much time on it. I'm not gonna resize these. Just gonna move them slightly. That is really huge. Yeah, that works. I mean, this is not very, this is not the proper way to do it, because I'm just doing it, you know, whatever looks good. You should take the data sheet and follow the text there, but I think for this board it's all right. And as long as these pads fit and this can be soldered so it doesn't rip off the board just immediately, I'll be fine. So what we do here is there you go. But yeah, the proper way to do this would be to generate a script or write a script that would generate these footprints, just, you know, whatever, from, I don't know how few they have, like 5, 3, 4, 2, up to whatever, 50 or something, and it would just generate all these footprints, because it is, there are rules for this, how these are generated, so it's definitely possible. Oh, what? Okay, fine. Then the ref. And the whole courtyard. Again, this should be better calculated, but good enough is good enough sometimes. All right, let me just change the grid. And we're done for the footprint, for the 2 connector footprints. Maybe just one thing. Just because it goes so much far outside that it will force me to make the board larger than it really needs to be. So 1, 2, 3, or 2, 1, 2. But it's really that small. It's actually smaller than silk suggests. You remember when I said that we were done? Like, nope. I lied, apparently. Too much. Okay, and this also allows us to shrink the courtyard, definitely. No, 0.6 millimeters into 3. I really appreciate the addition of snapping, like here that it snaps the lines to each other, because I remember when that wasn't there and like you were never really sure that you put them exactly on top of each other. It could have been like 0.0001 millimeter away, and it was just causing all sorts of strange issues. Okay, now we are done. I could have moved these also a bit in, but no, let's not overdo it. Yep. So I can actually delete this so I get it properly again later. Then we are here. The footprint was, right, that's the wrong one. And this is the correct one. Although I have to double check, like I said, the what is it called? Pin 1 is actually pin 1 also on the connector. On the pine and on the LCD, just so I don't get backwards. That would really suck. Although, I mean, I can solder the connector backwards, but then, yeah, all sorts of problems. So let's try to not do that. All right, so the backlight now. How long are we? Okay, we're 1 hour mark. Now, for the backlight, like I mentioned, it seems to be like a de facto standard, this way of doing it, two strings of multiple or of the same amount of LEDs, sometimes like 6, 8, 10, 12, I think I've seen. When researching for this backlight, I actually haven't seen this before. Like I usually seen either there's like one anode and then a cathode for each LED, and that's a lot more straightforward than this. So it took me a bit to find like a controller that will actually properly support this. And I see my stream is lagging right now. Hopefully it's because something was loading and it's done loading now. But yeah, I found this nice NCP 55006. It's like under €1, so it's really good. And it should work just fine because, right, I forgot to mention, like each string, like there's 2 strings, but they're connected, so each string is 20 milliamps they're connected, it's 40 milliamps needed, and then 18.6 volts for that backlight. So this one can provide 40 milliamps, no problem. Yeah, he doesn't mention that at all. Like, no, well, it does mention where. But because some of them only can provide like up to 20 milliamps, and that was a problem. And then very simple, just one inductor, diode, caps, a nice high precision resistor, and it should work, hopefully. So the question arises now, is the symbol for that in icon? It is not. There are, yeah. Oops. Although I wonder if we could reuse some. That would also work. So this one was a SOT 23.5, was it? No, it's a, well, they call it a TSOP, but yeah, isn't that a, I'm just trying to filter. I don't know if KiCad actually does that properly. If I can filter on number of pins. Oh, this is really hard to see. Creates what the heck is happening here? Yeah, you know what? It's gonna take longer to look for it than to actually draw it, even though, yeah. So let's draw it. So where do the backlight drivers? LED boost, maybe. Which category do you actually go? Driver LED, yes, that is correct. All right. And we can put a data sheet and sure, let's put a footprint as well. So is it TSOP? Let's see the drawing here. I just want to compare because this seems really strange. Okay, so 2.9 by 1.6, and this one is 2.9, yeah, by B 1.6. Yeah, it's, come on, it's an SOT 23.5. Right, this to this one is 1.9, and here is also 1.9, and then here to here is 2.4, and here to here is not pictured. Really? Okay, but it's between 1.6 and 2. Yeah. Yeah, right. So yeah, this is a SOT 23.5. Cool, good to know. I think I just closed my datasheet. No. Yeah, I did. All right, give it a second to open. Just copy this. Cool. Be bad. It doesn't have to run off of battery, so we're good. Yeah, I don't know why. For a second, I always get confused here. Name and numbers. Could there be a better way to do this? I'm not sure. Enable is an input. That's going to be out. OV in my bad. And that's a 5. That's a power input. And that's it. And then in the example actually, because that defines the routing. What does it here? FB is analog. Yeah, that makes sense. Can I actually do that here? Yeah, never mind. I could make it an input. Yes, right. That's not the best way to draw it now, is it? Unless I like rotate it 90 degrees. But there was a better drawing. Disappointing. And then maybe we make our own. Because usually with these boosts, the inductor just goes over, and then you have the diode, and then it's out, and then it's in. Or not in, but the other side. Yep. So for that part, we don't listen. And I'm gonna make it slightly larger just because, or actually there's no reason, because I won't be drawing the LEDs here. I will just have in and out. So maybe that's alright. But there will be a cap here anyway, so right. Yeah. Okay, I can always modify that. No time. There we go. Just let's check. Yes, correct. as we've proven scientifically. Oh, Kilobyte, hi! Nice of you to join. Is it crazy hardware stuff? It's kind of boring hardware stuff. It's like just a display driver. The display might be slightly crazy, but it's pretty standard stuff. Yeah, so this symbol is done and done. We can go back here and actually, let's leave that in the middle. They changed the behavior, and I don't know if it's a bug or not, but it is different that I press A and then have to click to actually have the dialogue, and that's definitely not how it was before. So what's up with that? Need to organize some things. There we go. Yeah, DSI display. Gonna be interesting. See, there's that issue again. Like, why is it dimmed? I'm pressing escape. I'm clicking away. Something is up. Who knows? So for enable, we actually here. And then this one will go something like this, one inductor. And then, right, that's how far I get. Right, so that's not the way I'm gonna do it. This is pulsing, like, because you can PWM it, but they actually say it here that it creates some noise. Where was the drawing? Anyway, there was a drawing that creates quite a lot of noise. So they say you can also do this averaging network. So you connect actually the PWM to the feedback and PWM that, and that gives you a lot better performance. And yeah, it's not so good. So let's not do that. And then it's also fine to just have it high and not PWM it. So let's see if I will even do that to begin with. Yes. Right. While we're here, what I do is a text, and then where was that math? Here, math. It's called rset, wasn't it? Or they call it R1, but here they call it something better. Nope, just R1. That's silly. Anyway, if I can find my place again, there it is. So the feedback resistor, it's the feedback threshold by required voltage, required current, and that is 5 ohm. And that's exactly what we will use. I keep forgetting there's no centering this. So I believe the closest value for 5 ohm is actually 5.1 ohm, because that's just how it goes. So actually, let's have a look. Because why not? Yes. So passives, resistor. Hope this is not too slow for the stream. 480,000 resistors. Actually, kinds of resistors, not even pieces. And then I really like this view because it's way like faster somehow to find this. And then thick or thin. Let's go thick. Right. So yeah, like you can find 5 and 499, but I believe 5.1 is actually more standard. Might be cheaper to get that one. Percent of 603 in stock. Give it a second. That actually didn't go so badly. Exactly, so 5.1 is the cheapest, and then 5.1, 5.1. Yeah, to even find a 5, there's no 5. Or was there one there? Nope. Yeah, so that should do, with 1%. Cool. So that's what we can use here. Okay, so where were we? We can put, oh, what happened to my window here? There. So the VCOM was 5 volt, I believe that was fairly sure of that one. So we can use that as the input. Just let me find my place again. Should have remembered the page number. Yep. Exactly. So we pull enable just into whatever we put in, and what we put in here. Nope. Let's go for this. For now. Yeah. And then we need a small inductor. Actually, it's so there's so much space here. We could use a large. I actually never used the large symbols, but this might be the one case where it actually makes sense. And it's still way too large. But there you go. So here we can do a 22 microhenries. Yep, then we have the diode. No. Let's go for a small one. Whoa, that's oh, shouldn't have undone it. Yeah, it doesn't matter much. Okay, and then this goes to the backlight, and here we put a cut. And we actually also need a cap right here. Doesn't. That's not my usual way. This is my usual way. Oh, you gotta be like that. Correct already. And then yeah, you know what? Something like that. Yep, so that's that one. There you go. And diode. There's the one, and that goes to anode. I'm thinking I might put a test point. The second measure it before. That's the anode, and actually these I just so it doesn't like get confused here, and you know what, actually there we go. Yeah, and on this side this is flipped, so it's just slightly confusing. Yes. So before 5.6 is here. I really don't trust this. Like, it's not gonna create a connection there, and I'm gonna get screwed. Like, I guess the ERC will detect it, but too close. And then this one, and this one. I think you can see this on the stream. Are like dimmed, and why? No idea. I don't know. I might need to install a slightly older nightly or wait for a newer, because this is not so good. Right, there's nothing to save. I'm just saving all the time because nightly. Right, so the 5.6 goes there. Okay. Here. And then we have the sense somewhere here. Or not the sense, the RFB 1K, not K, just there. To ground. And this goes before, right? So there's a 10K and there's a 150K on the other side of this. And nice cap over here. And this is where the PVM comes in, which there was. I'm fairly sure there was one. Huh. Alright, because there is no... Because the backlight is supplied in the connector, so there's no PVM signal. I wonder if there's something we could reuse, or do I have to provide it externally? Which is, I mean, that's fine. Yeah. I wonder if it's time to actually see what these are. Either. What? Or is that a... Or maybe that comes out of the display? What is SH? Let's see. Source right and left sequence. But it's an input, but then it's right. Ah, that's interesting. So it's hardware sequence control. That usually isn't that usually in registers, but not in this display. Okay, so it's lower high. Okay, that's why it's not on any GPIOs, because it's just here, and then that one. Those are probably non-mount. One of them, and you can select. And same with the standby. Was there a B at the end of that standby? and by B. Doesn't matter. But this tells me that all of these are useless to me. And this, there you go. We're getting somewhere. So right, J power. Yeah, there's the PVM, which I wonder could. I guess I can put it on any GPIO and then just solder the wire there, so it doesn't have to be exactly this signal. Yeah, I wonder. What does this say? That's the first thing I wonder, but delete. But I wonder what are these voltages here? Okay, is that 10 volt or is that 1.0? 10 volt. I might have to take a take a pine and actually measure these voltages. Although it doesn't matter so much for me, and I'm just looking for GPIOs right now. Don't need any voltages. I need 2.8, but I can get that from the 5. Where is it? I lost it now. There it is. Right, so the 1.8 actually is here. It comes from this LDO right there. Boom. Yes, these two. Then VCOM, we can check that in a second. Low and high, then VLED. Right, so these are not so useful. So I just need to figure out VCOM, which I hope is 5 volt. And then we're good to go. So just ignore these. Right, the AVDD, which is, was it 10 volt? What the heck does this mean? There's the capacitive touch. The VCOM is 4.3, which seems like a strange. And then what does this exactly do? Does it, like, you can short VCOM too, but then why is it twice? Let's just look for this again. Yeah, exactly. So here it says the 5, which I'm not sure that it actually is, but if this was correct, it would mean that AVD, like LCD, is also 5 because they're just right connected over. But it clearly is not, and it says 10 volt here. I wouldn't trust that. Okay, so then for the VCOM, yeah, I really don't know. Does this, how similar is this display to, or we could actually check the datasheet for the actual Pine display, which I thought I had open. There it is. VCOM. That's not so useful right now. So I have the Pine there. This is the official Pine LCD. Well, I'm not sure if it specifies the model, but maybe it's on their datasheet, or not data, on the wiki. Maybe it's here on the LCD that you can actually see. Oh yeah, there it is. So this is the datasheet for that display. Okay, so this 3.4 as it's said, which means I could actually use it. Right, so that one was 10. Oh, this is so useful. Right, there was the inverter. So I can get the 2.8 from the 345, that's no problem. Or I could actually have a separate connector for like a 5 volt that I can get on the Pine. I mean, it has the Raspberry Pi connector, so it does have 5 volt and 3 volt, so that... Oh, that's a big diagram. Yeah, exactly, there's a Pi bus. Yeah, you know what, let's do that. Then I don't have to worry about that VCOM, and if that's enough to actually power the backlight, the 3.4. Yep. Okay, so that's all we need from this connector. 2.8. So right, I was why did, where did I get it? Right. I got distracted because I was looking for the PVM GPIO, and then I got distracted by the voltages and all that stuff. So in conclusion, there's no GPIO for the PVM, so let's just slap a test pad on that. Or not. Test pad or header? Header, test pad, header, test pad, header. Let's make a nice header on that one. So this PVM, and see I can't rotate it, which is also, that must be a bug. No VCOM here, and then just to make sure the input range 5 volt, it should definitely take 5 volt, but it never hurts to double check. VBAT maximum 6, 5 is perfect. All right, so 5 volt. Okay, now I'm satisfied. So yeah, sorry, just a second. Yep. To check my phone, of course. 1:45 streaming, cool. Taking slightly longer than I expected, since this is so simple, but maybe it's because I talked about the things at the beginning. Who knows? All right, where are we? The grounds are all grayed out again for no reason, but we need a header. We need a header with this and this and the ground on there and a fiber, and that's kind of it, is it? Can I fit a test pad? No. Do I need a test pad here? Probably not. At this point. That's not right, that should flip. Something is up. Like I wanted on this side because it's nice to be consistent like that. But apparently I can't have that. Yep. Just triple checking at this point, I guess. 150, 10. Okay, I think that this side is actually done. Need to assign footprints, but that's alright. Okay. Right. And then we need a header over here. 1 times 4 times 0.4. Press P. 1 times 4. No, not 40. Oh no. The 0 is important. Connector. I don't know. GPIO. Which is not really true, but right, there's the pine, this one, that one, this. We need the LDO for the 2.8, and then we are good, I believe. Then we can run ERC and see what's up with that. Okay, so how many do you think the datasheet will specify for the LCD how many milliamps we can expect on that 2.8? I'm wondering. Temperature. Mm-hmm. 2.9 was the PCI. There's some optical stuff. There's testing. No, of course not. Actually, there is a way. Check the driver, which I hope is also called VCI in the driver. Otherwise, I have a document which shows how the flex is actually connected, which is really nice that they like. I've never gotten that document before from any manufacturer, so that's really nice. VCI. That will take a second. Okay, so this claims that it's not. Fine, gotta check the data sheet. Voltage generation. Sure, actually. Okay, that's not what I wanted. And this PDF has way too many pages. And it's not that big because I mean 300 pages, that's nothing in data sheets. Okay, there we go. So 42. Yes. And interesting. Maybe it could actually go up to 3.3, but let's go for 2.8. Yeah, I think I need that document actually because this is not so. I guess it's the VDD, but I have it in my mailbox, so it's no problem. And open that. And here. There you go. So upside down. So the VCI goes all the place. I'm just looking because, right, so they do generate an invert on, it's actually on the, it's right on the flex somewhere, or on the die, where they generate the higher voltages for me. How nice of them. So VCI goes to like VDDB, VDDA, VDDR, VGL, no, that's not it, VGL0. Okay, but it goes to VDDA. So you would assume that it's the yeah. So oh no. Show me current. That's not gonna, yeah. Wasn't it there? Power consumption 46. I was just there. That gives us a bit. Timing. It only has the sleep mode. Come on. I want to know the actual mode. Like, yeah, running. I don't know. Is no, maybe no. Is 100 milli enough? Is 250 milli enough? I would think 250 would be enough, but I mean, this will take forever to find. Like, oh, CABC, interesting. I don't think this panel uses CABC. I mean, cool microamps are cool and such, but how about actual current consumption? Do it. MCP 17, that's my go-to. And it has a 2.8 variant, and it's a 250, so I hope that's enough. So T23. Yep. Yes, that is the one. in 5 volt, P out 2.8 volt, 3 caps on both sides, done and done. And I think we will be done actually at that point. I mean, with the schematic, obviously. Right, this symbol sucks. There's the 5 volt and cap 1, 1. Can't do that, I guess. No. All right, that's the LDO. Boom, fastest LDO in the West. Move some stuff around. Okay, so what does ERC? Okay, ERC will tell us please run. All right. So 1.8 needs a power flag. Oh, did they make these arrows smaller? I feel like they did. Right, so 5 volt also needs, of course, a power flag. What was the last thing? Ground, of course. How could I forget? Finished. Let me just, have a last look, sanity, loot, check. I mean, this is such a simple board. Not sure why it's taking so long. Like in 20 seconds, it's gonna be 2 hours. But I guess, yeah, it's because I also created I did the 3D stuff and then the footprint stuff. Yeah, it adds up. All right. D and then we have these. Correct. Correct on this side. I think it looks good. Quite readable also, like compared to the way the datasheet showed it. Really happy with this. So then we move to, again, this is behind my camera. There. And it will take a second. All the caps can be 0603. Not these. I know Kaikad has good intentions here, but come on. Then There's only one test point. Right, because I made it a header instead of test point. That's fine, that's fine, that's fine. There you go. Let's see. Yeah, that should do it. Double check this, 23, 23.5. Then this is just a pin header, 24. No. What? There it is, missed it. And the diode, have it right here. I wonder if the inductor might need a custom footprint. SOD 123. I'll double check that. Was it in diode? Yeah, SMD 123. Yes, exactly. 1 to 3 means the pads are around. Okay, let's from pad to pad is 420, and from here it's. I can see it here. 420. Okay, so it is this one. I got bitten by this before, so yeah, I will definitely double check that. Or was it 1 to 3, or was it 3 to 3 that last time I used? Something like that. Because I think that's actually just the thickness of it, and of course I don't have a 3D model for this, which is a shame. But okay. And then for the inductor, not this. I have it here. Found a nice one. I wonder if it actually looks like this. That would be quite cool, although those are the pins, so you won't see. Let's open that one. 7 viewers. Oh my gosh, did someone tweet something? That seems like a lot, relatively speaking. Right. Okay, so it looks like that's kind of boring. And I mount it upside down just to have it look cool like this. Just a second. Yes. Right. So the size, the package here, there you go. It is 0.15 by 0.15. All right. This guy could have. Oops! Again, the camera in the way. Should have just alt tabbed. Oh no, no, you don't. There you go. Oh, that is just wow. That's just mean. It's better than a crash. 603. Seriously, that's just bad coding right there. Then we need a test pad. That's the one. Okay, now I forgot. A times B is point. Oh, that's inches. 3.8 by 3.8. So MD inductors. 3.8. How much is that in like these? 3.8. So I guess. No. 3825. That's an interesting footprint. So how much is from here? Here 4.8, but like from here is 3 point here. Okay, so it would actually fit footprint quite alright. What do they recommend here? H 254 millimeters. This is way more than 254, but that's fine. It's 4. And then here, wonder what that should be fine. Oh, it's not actually. It's actually these pads, not these, that are soldered. Interesting. I is 1 millimeter, so that's, there you go. You know, that could actually do. And maybe best way test again is with a 3D model, which I'm not sure if Coilcraft actually provides. Doesn't hurt to test. There you go. 3D models. Wowie. That's really nice. So then I can test it. Oh. Okay. Oh, that's okay. So official, they just hosted here. Yep. What accounts do you use? Okay, 3D, and give me a step file. Don't care. Don't zip it. Let me just save it in the proper. There's the render. It just took forever. All right. So let's go for this one. That concludes this part. Then and we are here, and I'm missing so many models. That's so sucky. Because I stopped that copying process there. Wonder if I could. No, just 1 second. Maybe I could just copy these folders, and that would be enough just to have nice models. Just makes it so much nicer. So what are we missing? We're missing resistors. Nice. Then we're missing the SOP. So the connectors don't show up. Is it because I have like virtual hidden? No. But also inductors and the diode. Okay. Now, cool. Why the 3D model missing here? Because of this. Right, so it should be, that's not quite the way to do it. It is fine for now also. Alright, we're getting somewhere. This one is called J, this one is called U. That's interesting, but it doesn't matter. Okay, so the inductor. Let's check that out. Okay. Modules, packages, inductors. Nice looking models, slightly slightly rotated. It almost looks like it's like a way smaller than just this big section is just in the way. I was wondering if I could get away with smaller footprint. Was the actual pins, what was it? It is. The actual pitch here, which like E is only 2.6 by 2.3. 2.6 by 2.3. And these are just not square. That's the problem here. Sometimes it would be nice if there was an actual like measure, like what's it called? You know, one of those measurements showing what's it here and what it is here. Because like I can check here. Like okay, it's like what is it, 7, blah blah. But like for this, it would really be helpful. 40 by 40. 254. Wasn't that exactly what that one was? You know, let's oh, it's just Callcraft. No, I didn't even notice. I think this will do. It just needs rotation. Yeah, this is better actually. What was this footprint called? Is it actually for this? XL4040. Oh, come on, it didn't save. Seriously, that's what I did some changes here, then I went to change footprint and that forgot, this closed this window and forgot my changes. That's not correct. Okay, okay, yeah. All right. This will not be a large. This will not be a large CD for sure. I think I will just label them word. Now what I can change is the default text size because it's way too big here. Copper. That's why. Okay, I see the problem. If I do here, it should be. Yep. Let's have a redo. And then yeah, like this doesn't always work for me. That's another thing. Like there should now be these two lines showing where my cursor is, and that's useful for this. Nope. Not this time around. All right. And C5. Then doctor, of course. E1. Might actually be easier this way around. U3 is C2 and C4. And the rest of this is all, yep, it's all. Here's a question. Do they have a nice recommended layout? If I can find the data sheet. which I guess closed or something like that. I guess they don't have they have, yes, that's not so great, because black and white and without the silk, like what the hell is happening here? Oh, and this is so low res. 5006 def. No, these are so useful. No, not the this. No, that's also the key. Why? Ah, I wonder if there's an application note, maybe. Drawings. Yeah, let's see, how are these Gerbers delivered? Yeah. You know, that actually this photo might be enough. If it's high enough res. It's a GIF. Why? Why is it a GIF? Yeah, going higher probably will not help. I guess good thing with GIF is it does not compress. Yeah, it removes half of the colors. Ooh, sure. I can't even tell the orientation here, or maybe 1, 2, 3. Yeah. Wow. Now let's try it just for fun. What is this? This is new. Show run. Whoa, that's new. And I'm not sure, is it help? I guess it's helpful if they're on top of each other. Let's try it. There. That's quite all right. Okay, so yeah, this. Then we have this guy right over here. With the diode under, and then it goes to where it's needed. Now C1, I believe that actually matches. That's like right over here. I'll probably either remove or move these later anyway, just so they're not in the way. Yeah, then C2, does C2 actually, no. What I can do is open the schematic and then see what it corresponds in mine. Oh, what the? Is a PDF? It is. Why is it? Oh no. They pasted a freaking JPEG in a PDF and called it a schematic. No, seriously. Or is it? No, it's actually, it does scale. It just scales like crap. What the? Oh, this is amazing. There's C3. C2 is this guy over here, which is C5. So C5 just goes over here. That's where all the ground goes. Right, so this is all like ground here with this included. That one. Huge via here from there to there. That's the 5-volt in. So there should be, where's the decoupling up for the 5-volt in? Need to put that, which is, where's that, the C1? Yeah, right, that's C1. All right, so how is that all of it? Is this all? Yeah, that is. That's just PVM shenanigans. So let's see. Does this one? R3 is needed to actually just even get the let K. Yeah, how does it go here? Here it's slightly different, but R1 is, all right, it's on the other side of the LEDs, which also makes sense. Right. Right, here A and K, we can have these huge, nice pads going. Yeah, this is where we are here. Actually, we can do this better. Right, these are all 603, so I can place them this close. That's not a problem. right? That goes here, that goes there, that goes there. That's really convenient. There's a flat fill here with this. Boom, done. Skip it. Okay, that should actually be good. And then, however, we need this. Right, and that's what is it? What is R1? Right, that should still be here. Yeah, that's no problem. Wow, that lines up so nicely. I'm so glad. So my tracks are 10 mils, and that's actually not a problem at all. I can actually make them larger. But LCD, the backlight is on this side, which is really good. Although it is, oh, it's flipped. And I can't flip it. Unless I did like this. Not preliminary. This. Oh no, actually, I can't have all these DSI lanes going under a booster switching. Yeah. No, that's way too much noise. So what we can do? What about something like this? Backlight. Although the backlight can go from the back. That's actually something I'm curious. Do I need to? It's flipped. So I might actually want to have one of them on the back and the other on the front, so that way I don't have to cross over the DSI stuff. Let's flip. See, that might actually work a lot better. And then the backlight is also on this side. Yes. Now let's go here. Like this. Then we could have, of course, needed there, but that's fine. We can have it just here. Oh, dang. That's the backlight. That's the LCD. That's the pine. That can go somewhere. This is pretty alright. Alright, that could actually do. Now only, okay. Because I have to think of how I will actually connect things, because the contacts are on the bottom. So with the LCD on the bottom, like when it is right now, the LCD goes from this side and it's actually facing down. So I can either wrap it around and then it's just on top of this board. That's quite alright, I guess. Or the pine here, the board is backwards and then the LCD is front. So it's like this. Then the LCD comes from this side and it's facing up. That's correct. So how does the pine look actually again in the like polarity wise? Is this useful? Not so much. No, this might be useful. Yes. Show me a good photo. Yeah, so this is actually silly. I'm not sure why they made it face inwards to the board. I don't get it. There was a choice there. But yeah, so the pins on this are on the bottom. So if it's on the bottom here, it's also on the bottom there. So let's see. I have to have it on the top. So if I have the flex cable going this way, then it's upside down and the pins are on the top, and then I connect the board and I have the LCD. So that works. It just goes here, arches around like that, which I think they show something like that. That's they had a plan for sure, but it just seems so strange that have the touch on this side, the display on this side. All right, so this will work this side up. Then this should actually be right. So that should be on the other side, and this should be on the other side. Correct. All right, we're getting somewhere. One. That's two, and then it can be wherever I want it. You know what, actually I want this on this, because, oh no. I was thinking the flex would be on this side, but now it will be on this side, so it's all good. So next thing is I would like them to be aligned. So on X it's in this one. Okay, so they are aligned. Cool. And then let's say from here to here, what? It's a nice number. It's 19. That's a nice number. So that allows me to this is the middle. That is wrong because I can't math 9.5. This is the middle. How many lanes do I need? Like how much space do I need? Not so much, but it might be hard anyway. I think if I could move this more in, but something like that. So just to draw a rough sketch of the board. It's gonna be something like here. Yeah, that shouldn't be on the silk, but yeah. How big is this? Because I'm thinking I could like keep compressing. I could make it smaller, but do I? Why? Why spend time on that? No. Yeah, there's no point. Oops, that's not right. Yeah, I guess what there is absolutely no point in making this any smaller. There is a point in making it rounded because that just looks nice. So that might be too round. No, but let's see how it looks. That is really round. I'm thinking I could make it a very fancy shape over here, which makes... Would it look nicer though? Now let's... I have time. Let's have a little fun. That's gonna look strange. Yeah, so what are people doing? What is happening in the chat? There's 4 viewers. We can have a discussion. This shouldn't be just one-way conversation. This is gonna look crap. Yeah, this looks like shit. Tell me, what are you working on? What are you doing? How are you spending your Labor Day? I guess May 1st. Does your country even have that? Maybe you're at work. Do tell. That's good enough. So boring, although. Actually, you know what? I just thought of a thing. I don't need to have it this big. If it's upside down, like if the other connector is on the other side, there's no reason for it to be this big, actually. Yeah, I said I wouldn't do that, but I guess I can't stop myself from optimizing like that. You know what? This is slightly close. But maybe that's fine. Yeah, that's so much. That courtyard is way too big. Seriously, this snapping to edges, so good, so useful. Like before, I would have to zoom in just to make sure it was actually. Oops, and I missed something. Oh, there it is. Yeah, this is not so useful, you know. Like, oh, it's exactly at this point. Thanks. That is, I sure know where that point is. Okay. Reset. Mm-hmm. I'll move this because it can be like here. Just this bottom footprint is throwing me off. It does not have to be exactly here. So what I'm thinking. Route some of this power stuff. Right, so I can have a big wire here, or even better, have a thick wire there. Good. That. All right. So, how thick is thick? 5, that's gonna be like 20 mils. 6 is what? That's 24 mils. Holy crap, why? Seriously. Oh, it reset my. Oh, no. My layer visibility settings. 0.7, that's a fake one. There you go. Whoa. There you go. I don't think it's like an insane amount of current going through these, but it looks cool, that's for sure. Could actually use a bit more annual ring. It's fine. So what we can do here, what we should start with actually is a ground fill. On the top ground, sure these settings will do for now. That one, and then duplicate, edit, bottom, boom, we have both. Oh, it's so close that it's actually okay. Let's move it slightly slightly come on. Make these fills need a slight adjustment. Interesting, that's like a new way that those nets had different names before, I believe. It was more just like net 1 to 3 or something, wasn't it? Yes, minimum width is actually should do. Shouldn't that do it? No, that's the one. 0.3 clearance, that's still like 10 mil, that's fine. And there you go. It's 2.2 and same on the top. 2.2. Cool, that looks, I think, quite nice. There you go. Now we can have a 5-volt flood fill here, and then Wasn't there one more? Right. Flood here, there, flooding everywhere. Okay, let's try the 5-volt one first. Ah, sure. Just priority. I don't remember which way it should be. So we'll see. Nice. All right. Could it have a rounded corner? Yeah. Not really. Yeah, that's the thing. That's actually nicer. Okay, so we have some serious 5-volt going on over here. That should be fine. Then this net, this unnamed net over here. D question mark 15 pad 2. Okay. I think that's one. Prio 2, was it? Yes. Ah, that looks quite cool actually, with the rounded corners. Nice. I approve of this. But what we don't need is these to be so far. Right, because the ground floods perfectly. What was the width? I don't quite remember. It's like 5, and then via diameter 5, the drill of 3. That's too small. Thanks for that. There you go. Okay, so good so far. What I could do is traffic was this 0.7. Oh, I see. Wow. Quite big there. See what? That's a bit strange looking there. Yes, so for the anode, we have here, there's a test pad, there's the PVM, it has to go just like, or actually it will go around, so I don't get any here. PVM, yeah, don't PVM under your DSI. There a problem with the ground? Nope. That's just, that might take a second to get used to. All right. Right, there's the 2.8, the 1.5 comes, 1.8 comes here, and just go whoop. Okay, so I think it might be time for a differential pair. Woohoo! What's the problem now? Okay, let's start with this, although it's there we go. Yeah, that's crossing these. I don't know. Hope it works. Is it the clearance problem? What is happening? differential pair width, clearance is 0.2, track of 25. What's your problem here? I don't. What? Was it Alt6? Yep. Thursday. Now I'm really confused by. This is tight. And to be honest, there's no reason for it to be so tight. Yeah, let's, because I want some ground between these. Actually, let's start from the middle. I'm still not sure what seems to be the problem here. Really annoying. Okay. Yep. And yes, I want those grounds between them. And that's perfect. Now for length, that's like you want the clock to be longest, but also the data lanes. Let's 0.8. Yeah, then there's no ground there. But now they are like 16 and these are 12, so that's for sure better because the clock should be the longest. And then the lanes themselves, 12, 12, 12 and 13.6, that's, I guess that's enough, good enough. Could I move it? Thinking. Yes, that's perfect. That's better, definitely. So where are we now? The PVM is there, ground. Yep. The TE should just go be a TE, so that's for the reset. We can go somewhere here, go under, and then so that takes care of that. And the 1.8. Yep. The ground needed some help there. Test pad, cool. Um, Thinking about this one now. And as I think of that, I do other things, of course. Now this could be anywhere I want it, so why not here? Makes it easier to route. There you go. That makes it actually also easier to see anything. Yes. Getting there. Right, 1.8. Have it here. Okay, the 2.8. Get that, just have to place the LDO somewhere nice. Right, so let's see. Hard to see like with this because you have both front and back. Like it could be here, but then I have to. What do I have to actually? Maybe I don't have to do that much. Oh, that's not good at all. Right, the PVM also, so maybe let's do that one first. No real reason. Yes, T is connected, no, the PVM is connected. So we just, yes, 3 volts. So if I put it here, what is the downside? Not 3, that's 0.8. Just to go there, which can go just, yeah, the downside is good, go just down here. Because if I put it here, then I need access to 5 volts, which is here, so that's also not huge. Yes, right there, up there. Should be able to add corner, yes. Cool, how does that look? Nice. These grounds don't connect for no good reason. No, like seriously, why don't they connect? I mean, I can get when I do like here to cut off that round, but right now it should be fine. Let's go for 0.4. I think I'll rearrange this slightly here. Let's see. 1.2, the 2.8 here. I don't want to go like around way here. I could move this, but where should I move it? I mean, there's so much space. Just don't notice because I can see both layers. Like this is an available space. There's no problem placing here. It just feels like I can't. That was actually 0.5. Hey there, no problemo. And that gives me a nice way in here. With only a slight headache. Never mind, no headaches. No, oops, no headache. Okay, this, what was there one? There was some ground issues. Wait, what? This whole thing is not connected to. I spread, but I will pitch it, so that's no problem. There you go. Okay. So that's actually it. Fine on this side, LCD on this side. Wow, my voice is kind of escaping, going away. It's been 3 hours. Yes. one could actually use. Perfect. And then here. Just so the ground kind of spreads around. There's some stitching over here, and then like here, and not there, not there. Just a few. And re-put the anywhere there. No, that should do it. Got this strangeness over here, which I still don't quite understand. Okay, and this is slightly out of bounds. These might all need to go one step back because of this via. This is just a total mess. Yes, so there you go. Just looking if there's anything that looks wrong. The connectors are there, so that's no problem. This needs a silk. The silks need moving. Here and what was the shortcut for flipping board? Maybe there isn't one there. Go. LDA. Looking good. Then I need silk for these on both sides, because why not? And I don't know which, like this is supposed to be the front. I can have that on both. So to do this properly, we need the proper grid. and back to reality. And then we flip it, and that's the goal. Flip it back, wherever it is, there. Yeah, you know what, that was actually correct. Oh no. Okay, now I'm super confused, but whatever, as long as I can get it to work. Nice final touches, always needed. All right, and so right. Then I can do one more thing. Just off screen. If I can find it. Come on. What's the holdup? There it is. All right. So what I can do now is add a nice logo. Oh, I hope that doesn't take forever to load. It doesn't. That's nice. Solder Partey. That might fit on the back, but not here. Okay, this one has to do, and it just, yeah. Then I can write here what it is, and here there's quite a lot of space. Except it's really hard to see that space. And front wires, front copper. Just trying to navigate the vias because there is no silkscreen on the vias. So let's see. Yeah, like that. And then this I can just move here. There. Not quite right. And I think for the last thing is it's May 2019. Here I thought I had so much space, and yet not enough space. Or just call it this, and that works too. And again, navigate the VS. I don't know if that looks good with the other text. It might blend in. Oh, that works. Just a solder party. Could go lower. And then a VI and the O. Yep. So that works on the back here. And then here the same. And then we are done. Done. Actually, I just thought that this board would be used kind of on the side, like because the display connects here, but then the viewing is this side up. So, but yeah, doesn't matter. Right, flip the board back. Okay, I think we're done. Right, that's under, not VI moved. Wanted to check it, but it seems to be all right. Very good. Yep. Cool. I'm really happy with the roundness here. It looks actually pretty cool when you just look at the copper. That's oh no, that's gonna kill Dream. There you go. If I remove the solder paste, nice and shiny. Cool. Cool. There's things like doesn't quite go here, but I think it's in the middle, so no one gets it. Which is probably fine. Right. Oh my gosh, I forgot. I sure hope it's correct. Like I mentioned at the beginning of the stream, let me just remove this, of the pinouts here. And I sure hope they're correct. So let's see. Right, that actually makes maybe sense to look like this. So 1.8 and the 1.8s are here. And if we look, which one was it? This is pin 28. Yeah, this is like the high numbers. No. Maybe higher size image. That one should do. You know what, while this loads very slowly, I'll be just right back. Okay, we're back. So this finally loaded. Oh, come on. Excuse me, I was promised a way larger. This is a pin 1 marker, I think. Looks like it. So if this is pin 1, I'm gonna close most of these actually. Maybe actually these photos are, yeah, that's pin 1 marker. So that is pin 1 there. And close that one as well. Just looking at pin 1. So that means the 1.8 is here. And then again, if I flip it, it's at the top here. So we are still in the money. Or this was actually the top, correct. So yeah, doesn't change anything there. So that's correct. And then here, hopefully, I can see already that it is correct just comparing the LCD flex, but can verify here. That yeah, the LED is pin 1, which is pin 1 marker is here, and pin 1 in the LCD is at the bottom. So that means, yeah, it's gonna be correct. This is the bottom and the LCD is here. So, phew, we're good. And yeah, we are done. I think that's all for this LCD. Have the backlight, have the 1.8, the 2.8 comes from there. PVM, T is just optional. Okay, so I think that's gonna be it. I'm gonna order these now and wait and see. For the future, I'm thinking what else? What's next? What next? I guess. Not much kicading in the near future, except maybe because I'm gonna probably make a tiny prototype for the keyboard for the handheld while I'm waiting for some other parts for the except notebook keyboard. So when those arrive, I can continue. Like I'm switching context between these two. I'm gonna make like, I don't know, 3x3. So I need a tiny PCB for that. I will probably design that, but that is literally like not even 30 minutes probably, because it's just 9 buttons, header, and place them. I'm not sure if I'm gonna make a stream for that, but I'm gonna do, yeah. Well, let's see. Let's not keep it any longer. We're closing in on 4 hours, actually, in what? In 3 minutes, in 4 minutes. See, there's something so strange here, like some of them are grayed out. Oh yeah, you know what, actually, I haven't done one thing. I haven't done this thing. Footprint warning, no. The courtyards overlap, and that's fine. Okay, that's wacky. So we're good. Everything is fine. No problems here. Quite happy with how this board turned out. Good. Okay, not to just for no reason to keep talking about nothing. So thanks for watching for these who hang out, and thanks to those who left, like who came and left for some time, just hang out. I'll announce the next stream at some point, and cool, that's it. See ya, thanks for watching.